Hello and welcome to Console Cowboys. So in the last video, we subscribed to the pending transactions that are sitting in the mempool. Then we took a look at the data that came back. We checked out the format of it. We parsed that to what we wanted, which was the transaction hash. We then used that transaction hash to grab the transaction data, and then we took a look at what was there. What we're going to do now is apply some filtering to it. So in the regular transactions video, we filtered out by those 4-byte function values so that we could monitor certain functionality. What we're going to do in this one is we're going to monitor a specific contract so that we can see all the calls to it, and then you can further apply more filtering if you wanted. This could be useful if you were looking for certain transactions that you were going to attack that were sitting in the mempool. So this is actually going to be very, very simple, and it's only going to be a few lines of code. What we need to do here is we need to first see what we're getting back from the last video. So just as a refresher, what we were doing is we were running this, and then we were pulling back the transaction data. So this is all the data from the transactions in the mempool. So what we want to do is filter all of the calls to a specific contract. We can do that by monitoring the to address right here, and that'll allow us to see all of the functionality that's being called on a specific contract. So what do we want to monitor? I thought we would monitor some more Uniswap stuff. So a couple videos ago for your homework, I had you call the Uniswap factory contract, which is used for creating pairs. And you had to create some nested loops that auto-created some more connections to other contracts in order to grab those pairs and then list them all out. That got you familiar with Uniswap a little bit, and you had to figure out how to do things that were a little bit more advanced. What we're going to monitor this time is everything going to the router contract. Now, the router performs requirement checks needed for swapping tokens, adding liquidity, and removing liquidity. So what we're going to simply do is monitor all of the transactions going to the router, which may be performing things such as swapping of tokens. Knowing how Uniswap works will help you with a lot of things such as front-running transactions, sandwich attacks, or creating bots for arbitrage opportunities. So hopefully this is of interest to you. This is going to be a very simple proof of concept, just making sure we only see calls to that router contract. You can do whatever you want from there. Let's hop back in our code, make a couple simple changes that allow us to do this. So in our code, we're pulling back the whole transaction by using the get transaction with the transaction hash. Let's put our transaction into a variable called transaction. That way we can parse it out. So now that we have that, let's just print out the to address to make sure that we have the parsing correct. So we can easily do that by saying print transaction, and we just want the to address. And let's make sure this is working. And that appears to be working, so that's perfect. And then now that we have that, let's use this and then compare that to the address that we want and only print it out if it's the correct one. So what we're going to say is if transaction 2, and what do we want that to equal? We want to equal the Uniswap address. So we'll say web3.toChecksum address. Because if you remember, that will put the address in the correct format. If where we're grabbing it from, it's in an incorrect format. So we'll grab our router address right here and we'll hit copy. And we will print it out. So boom there. And then let's hop in here and let's say print two. So now it should only be printing out this particular address if it equals the transaction 2. So we'll only get this address printing out if it's properly filtering. So let's try that. And I'm doing this slowly rather than just putting a bunch of code on the screen so you can learn the process of kind of going through and figuring things out slowly, not just giving you code, because the process is how you figure out things on your own. Okay, cool. We have a couple hashes coming in. And now we just need to make one small change before we can look it up on Etherscan, and that is we need to switch this out to the hash value, not the to value, because the to value is always going to be the same. It's just the router address. We actually need the transaction hash so we can look it up on Etherscan. How do we do that? By transaction hash, and then we'll print that out. Now that should give us back a weird format, but I'm just going to show you that so that way you know what to look for when you're doing things. So yeah, it brings back this format right here, where you have it in bytes and then you have it like this. So of course we need to do the 2 hex like we did in the previous video. So web3.2 hex, and that will put it in the proper format for our transaction hash that we can look up on Etherscan. So let's do that now. And we should get back transaction hashes now that are coming in from that router address. So let's grab this first one here and we'll look it up on Etherscan. And it looks like we have 4 block confirmations already, and it was successful and happened about 43 seconds ago. Now this is a swap for noise GPT for 0.11 Ether on Uniswap v2. And this is going to our EF1 6B, which is our universal router. If we look back here, we have EF1 and it's ending in 6B. So that's perfect. We are successfully monitoring transactions to the Uniswap router contract. In this case, we are monitoring a swap transaction between Noise GPT token and Ethereum on Uniswap v2. So this is very, very powerful. It enables us to write bots that monitor things. It enables us to monitor transactions that maybe we're trying to front run or sandwich attack. It's really up to you what you do, and what you should do now is play around with the various things, such as parsing out for specific functions or other contracts, and think about what you want to monitor and just play around with it and start trying to monitor it and write code that builds out software to do what you want to do. So it's pretty powerful. We can also cruise down through here. You can see, okay, these were ERC20 tokens. We had some wrapped ETH that were, exchanging with Noise GPT, and you can see the pathway for that through the pools. And then if you want, you can also go to more details and you'll see, okay, here's our 4-byte value associated with the execute function. So again, much like the previous transactions, you could start parsing out for those 4-byte values along with to addresses, along with from addresses. Maybe you're monitoring between 2 addresses. It really depends what you're trying to achieve, but hopefully this is useful for you, and hopefully you learned something in this video.